Okay, good morning everyone. So today we'll go into the lab sessions. Before that, please open your project 32 folders, the VC++ project files, and also the website, thepadlet.com/gaussian/csa1. The link is on the screen. So we'll continue with one we have learned. The new commands you're going to learn is the exchange, the XCHG. So this one is very simple. You can copy the code and put into your project 2 folders, VC++ files. And basically you can delete all the core dumps registers because we're using the Visual Studio, so we can see what actually happening by using the debug mode. Okay. So let's see. After you copy it, the same thing, you do the build projects. After you build, remember to put a red dot on the coding, this first line of the coding. Then you go into debug, start debugging. Okay, then you should be able to go into your debug mode. Okay, when you're in your debug mode, debug Windows, memory, debug Windows registers. Okay, so we are using the register in these operations exchange. So basically they're exchanging the data inside the two register. So the first code AX and BX, so means I will change the data in AX into BX and BX into AX. So let's step through by clicking this one. We step through it. Okay, then you can see they're basically changing the AX and the CX, BX data. So the next line they will change the AH and the AL. Okay, so AH should be this one, CO, C0, and AL is the 00. So let's step through again. So they are just changing. So for exchange, both of the operands must be at the same size. Okay, they cannot be the different size. The same thing, you're able to change between the register and also a variables. So now I want to change the data in variable 1 and a BX. So before that, let's look into what are inside your variable 1 location. So inside variable 1 is basically a 0010. So it's a this the LSB and this is the MSB. So it's basically 1000 as same as what in here, 1000 hexa numbers. Okay, then maybe I put this. So let's step through this line. After we step through, then you can see your BX become 1000, and then your variable 1 become FFCC. Okay, the last one we try with the whole registers. So we are changing the whole EAX with the EBX. So you can see they're actually changing the data inside. Yeah, so this is the first command we're going to learn today, the exchange XCHG command to change the data between two locations. And remember the thing, for this command to be works, both of the operands should be the same size. AX should be same as BX, AH should be same to AL, okay, or BH also can, but they cannot be different size. Okay, so the next one we're going to learn is the direct offset. So for direct offset, you copy the code and put into your Visual Studio VC++ files. Then go into the debug mode again. Okay, let's see what's going to happen if we. So this is array b plus 1. Okay, array b plus 1. We move array b plus 1 into our EAX register. Then we're using the Z0 extended mode. So before that, what is your data in your EAX is this thing 0019 FFCC. Okay, it may other values inside your computer. In my computer here is 0019 FFCC. Okay, before I run the code. So after I move the code, step over, it becomes 20 in hexa numbers. So what does it mean? Okay, so when you look into the coding, your array B is starting at 10 and they are in the byte data. Every location in memory minimums they can point to a single byte. So the first byte is a 10 hash, so means array B is basically holding the values 10 hexa. Okay, then array B plus 1 will holding the 20 hexa, the next location, the next byte. Okay, so let's say if it's array B plus 2 is plus 2 here, then the thing inside your EAX will be 30 hexa. Why we need the ZX? Because we are moving a byte into a EAX which is 32 bits. If we don't have the ZX here, then when you build, you are having the error that two data are not the matched size. Your EAX is a 32 bits double words, but the array B is only byte values. Okay, so the call down register, you can delete it because they are just calling the register out for you to display. The next one, if we have a bracket array B plus 2, then what will be happen? Is it going to move in 30? Let's see. So now your EAX is a 20, so move to the next one. So they were moving the 30, the next one. So either you have the bracket or don't have the bracket, they are doing the same thing. Okay, but normally people will put the bracket. You put the bracket to let people know actually you're moving the content pointed by the values inside. Okay, so this is called direct offset. Okay, then the next one you can try with the direct offset 2. Copy everything. We have to stop the debug mode and put it into here, and we just delete the column. Okay, then we just go into the debug mode. Okay, so if we move array W plus 2, array W plus 2, it should be which values? Array W plus 2, let's see what happens. So now the EAX still the same, the default value 0019 FFCC. If we step through, then we were getting the data 2000 into your EAX. Why this happened? So your array W is pointing to the first location, which is a word. Okay, so they are pointing to this value. So they add 2, they will go into the value 2000. So how is this thing working? So let's look into the file here. Let's look into this one. Okay, so let's look into the array here. So let's say this is our data. Our data now is array W, and it is pointing, so this is our memory location. So the array W is pointing to the first one. It should be 0010, then it's a 00 2000. Remember how it's put 3000, Then the next one is 4000, right? So array W is basically pointing to these locations. Okay, so when we move array W, they will move according to the size of this array W. So this array W, what we do is we define as a word. So when you move something, they will move a word which is 2 byte. Okay, so that's why when you move array W, they will move 1000. So then array W is pointing to these locations. Then you you using the coding move the ZX EAX array W plus 2. So this is array W. Okay, this is array W. Then this is a array W plus 1. Then this will be your array W plus 2, right? So when you go to these locations, when you want to move the data from this array W plus 2 locations, then they will refer to the size of your array W. Since your array W is a word, so that's why they're moving 2000. Okay, you can try to change the code to make your yeah, I think the code is inside here. We look into the next one. The next we go into the Visual Studio again. So the next one is array W plus 4. Okay, so if it's array W plus 4, then you look into your coding here. So it's plus 1 plus 2, this is a plus 3, this is plus 4. Then they move in array W plus 4, so they should moving 3000 into your EAX. So let's see. Into EBX. So EBX will become 3000 here. Okay. Then the next line, they're moving something array D plus 4. So you can see in this one, we're just using the move. Why we're using the move instead of move ZX? Because the previous one, all of the words data value we're moving in is in word, but we are moving into the whole 32-bit register. So that's why I need to have the ZX. 0 extend the bit we are not using. Okay. So this one ECX, we are moving from array D, which is a double word. So they are the same size. So we don't need to use the 0 extend. We can straight away use the move to move in data from this location into ECX. Okay, so array D plus 4. What are the values they're going to bring in? So let's step so ECX. So this is a random values in your ECX now. So if we step through, they are bringing in number 2. They are bringing number 2. So why is this happen? Then we have to look into the array again. So this is your array. Okay, so the first location is using array D. So what is the values inside array D? Should be. If you don't know, then you can go to your window memory again, search for the value array D. Then you can see the first value should be 0, 1, right? So the first one is 0, 1, followed by a 0, 0, then another 0, 0, then another 0, 0. They only followed by your 0, 2, right? So why this thing happen? Because you are define your let me draw everything first, then followed by a 0, 4 here. Okay, can you see the okay? So this is a whole array. Okay, this should be a whole array, but we look into the array 1, array D first. Okay, so we are define array D as a double word. So when it's a double word, they are using 4 bytes. So there's 1, 2, 3, and 4 bytes. So you are define it as a 1. So they will make it as a 4 bytes values, but it's equal to 0, 1. So it's this is equal to 4 byte, but this is value 1 only, right? So that's why the beginning all are 0, 0, 0, 0, 0, 1. Okay. because you define as a D word, you define as a D word here. So that's why they were using 4 byte. For the previous one, you define as a word. So when they put into array, they're using 2 only. Okay, so if you define it as an array WD word, then using 1000 hash, what should be the values inside your array? If it's using this one, then the thing inside array should be 0 0 0 0 1 0 and 0 0, right? When you put it in a horizontal way, it's equals to 0 0 0 0 1000. Okay, so they'll make it into 32 bits, but the value is still the same, still the values you want, 1000 hexa, right? So same go to this one. Since you define as a 4 bytes and you put it as a 1, so that's why they put it into 1 byte, 2 byte, 3 byte, 4 byte as one word, but they are still remaining the value 0 1 as you define, because you define in your coding D word 1 2 3 4. Okay, so if they want to move array D plus 4, so same principle, array D, this is array D plus 1 plus 2 plus 3 plus 4. So they are moving starting from this location. Then when they want to move, they will refer to your array D size. What is your array D size? It's double word. So they are moving in the 4 bytes here. Okay, they're moving in the 4 bytes here. Okay, so there's a question. If I'm moving in array D plus 5, what will be the data inside my ECX if I'm moving in array D plus 5? Then the same thing, they will come into this location, they will start to move from this location, then they check what is your array D size. It's a double word, 4 bytes, so they'll bring in 1 2 3 4. So the data inside should be a 0 3 0 0 0 0 0 0. If not, you can try to change the coding. So let's say we change the coding here, plus 5. Okay, then we go back into the debug. Okay, the first one, I go to register. The first one, step 2, step through. Look into your ECX, array D plus 5. It's same as the values here, right? 0 3 0 0 0 0 0 0. Okay, so hope you understand how basically they are moving something by using the direct offset. Okay, then the next one, we are looking into the increment and decrement. Let's look into your screen one. Okay, so increment and decrement is very simple. When using increment something, you put the operands, they will increment by 1. Decrement, the same thing, they will decrease by 1, the numbers. So it's quite straightforward. Okay, increment and decrement. Okay, the next one we want to look into is the add values. Okay, we look into the add array by. So we copy this one and put it into your Visual Studio. We can cancel the call dump. Then we put in the red dot and go into the debug mode. Okay, after we go into the debug mode. Okay, so we go into the Visual Studio Code. So this one is just basically adding something into your array using the add command. Okay, so if you're using add command, so let's step through the first line. First line is just simple, moving array B values into your EAX. So basically they are moving in 80 hexa into your EAX. So if we step through, then your EAX become 80. Okay. Then the next one, they want to add some values into your AL. So they must be the same size or same size also. When you're adding something, you're adding a byte because the array B is in terms of byte. So you must put it into the AL instead of the whole EAX. Okay. So let's step through. If array B plus 1 means array B is pointing to 80, plus 1 they're pointing to 66. So means you're adding 66 into your 80. So you get E6 in your AL at the end, right? 80 plus 66 in hexa, you'll get E6. Okay. The next one, you move array B plus 2. So array B plus 2 is plus 1 plus 2. You're moving A5 into your EBX. Okay, so then you add your AL and BL. So when you're adding two registers, this they will store at the first location. Okay, they will store at AL. Okay, if you have two operand here doing the add, this is your destination. The same thing. They will store the result in this register AL. Okay, so let's step through. So now your BL is A5, your EAX is E6. So E6 plus A5 equals to 8B. So the result will store in AL here, 80B. Okay, so this is the example of the add command. So the next one we're going to learn is another command called offset. So offset is very simple. It's basically get the locations of the data, the memory locations of the data. So you copy the code and put it into here. I don't need to copy the code down. And stop. Put it into here. Okay. Then let's see what happened. Yeah, let's put it debug. Start debugging. Okay, then we see what happened. Your ESI. Okay, your ESI now is a random value here. Your ESI is this one, the one highlighted here. Okay, in your visual screen, you see it's a highlighted one here. So let's step through. Then what happened? They are moving in 44,000 into my ESI. So what does this offset mean? Offset means I'm bringing in the numbers of these variables into the register. Okay, so let's look into your variable B. So your variable B location is at 44,000 here, as shown in the screen here. I'm not sure whether you can see it, but it's the address location is 44,000. So it means the offset command is basically moving in the memory location numbers. It's not moving in the values here. They are not moving in the values pointed by variable B, right? Variable B should be -1, but they didn't bring in the -1, which is FF, but they're bringing in the address numbers 44,000. So if you're using offset before the variable names, means you are moving in the memory locations or memory numbers of that variables. Okay, so we can try with another example again, the offset. So let's see what happened. Again, copy, stop. Okay, so you copy again and put it into the coding here. And sorry, should put a red dot. Okay, then you'll stop here. Go into debug mode. So the first one, the same thing, ESI moving the offset variable B, right? Let's step through. Your ESI become the location 44,000. Then the next one is another variables, which is a D word variable B. So what does it mean? Let's step through. Then your EX become 44,000 again. Okay, so when you are using a variable pointing to another variables, you are basically moving in the memory location also. Okay, you are not moving in the values here. Okay, you can also do it in this way. You're using another variable's name, but must be using the word because they are using 4 byte. So using one variable name, the word, another variable, then when you move in the values p will b, they are actually moving in your locations of this variable b. Okay, same as the offset function. Okay, the next one you're going to learn is called length of. So let's see what is length of. Stop debugging. Okay, so this is my double variables, then followed by this clear. Okay, let's see the first two lines. I'm moving 0 into the EAX and EBX. Okay, so I clear the data in EBX, EAX. Then the next one, I'm moving length of my double into the move. Okay, so what's the meaning of length of? Let's see. So I move into EAX. So EAX now is 0. So I'm moving, if I run this code, your EAX becomes 6. So what does it mean? 6. Length of. So length of is basically let you know how many elements inside your my double array. Okay, you have 1, 2, 3, 4, 5, and 6 elements here inside your my double array. Okay, so that's why you are getting 6 using the length of. Okay, then the next one we're going to learn is the type. Okay, let's look into the type. So for type, you do the same, clear EAX, clear EBX, then you move in the type my double into EAX. So your EAX become 4. So what does it mean 4? Type. So if you're using type, they are basically giving you the size of this my double variable. D word means they are 4 bytes. So that's why I move in 4 into your EAX. So if you're using types, they are telling you what are the size of these variables. So the type is 4 bytes. So that's why they're moving 4 into your EAX. Then the next one, if you try with the clear is in terms of byte. So your BX should be equals to 1, since it's a 1 byte. Right? So your EBX become 1 here. Okay. Then the next one we want to learn is size of the array. This one. Okay, copy, put it here. Go into debug. You do the same. You clear everything. Then the first one you move in length of. Then the length of my double. So the my double is how many? There's 4. So that's why you move 4 into your EAX. There's 4 elements in this array. Okay. Then the next one is the size of my double. Size of my double equals to 1, 0 here. So what is actually the size of mean? Try to think about 1, 0 here means what? Then the next one is type. Type we move it into the ECX. So you move type D word, so it's 4. So it's 4, then this one is 4 also. So basically size of is the multiplication between length of and also type. So you have how many elements here? Length of, you have 4 elements here. Then each element is how many bytes? using the type. So each element equals to 4 bytes. So the total size of this array is how much? It's 4 times 4 equals to 16. So there are total 16 bytes. So the size of this array, my double, is 16 bytes. So 16 bytes in a hexa numbers equals to 10. 16 equals to 10 in hexa number. So that's why you get 10 in your EBX. So you can use this thing to complete to calculate your size of the array. Okay.